Hello everyone, welcome to the Hello World of Machine Learning series using scikit-learn. This is chapter 3 and in this particular chapter we are going to look into linear regression, our second machine learning algorithm. We have already seen our first machine learning algorithm KNN in chapter 2. Just a reminder, these chapters are in sequence from 0. I'll highly recommend you to go ahead and look into all the chapters 0, 1 and 2 because I'll be using the dataset generated out of those chapters in all the subsequent and current chapter. So this is what we are going to look into this particular video. We will see what is linear regression with a specific example which will be applied on same dataset which we have generated in chapter 1, and after that we are going to look into how to apply linear regression using scikit-learn. So this is the dataset which we have generated in chapter 1 and also used in chapter 2. The features of this data, the x-axis is called source of agricultural product, selling source of agricultural product at farmer's place, roadside, town, city and downtown. And y-axis is the price point. So I get the same thing at farmer's place at $12 and at downtown for $84. So farmer's place is an index 0 and downtown is index 63. Now considering the same data set, let's see what is meant by linear regression. Linear regression is all about plotting a straight line between all the training sets so that we can find the best straight line. I will come to what is meant by best straight line in a moment, but this is what linear regression is all about. Now, since it is related to a straight line, all of us must know the formula of a straight line called y equal to mx plus b. Some people write mx plus c or alpha dash or plus alpha. So this is the normal formula for plotting a straight line. So here, if we have y and x in this particular training set, we need to find m and b so that we can plot all the points. Here y is what we will get and x is what we will provide. Let's try to find each and everything. So let's first find m. M is slope. Slope refers to change in y divided by change in x. So in here I can say that slope refers to y2 minus y1 divided by x2 minus x1, change in y, change in x. But just understand that y2 minus y1 and x2 minus x1 is straight line between 2 points. Here we are considering a straight line between 2 points, which means we will take first point farmer's place $12 and we will take downtown which is 63 miles and $84. So y2 minus y1 will be 84 minus 12 and x2 minus x1 will be 63 minus 0, which will be 72 by 63. On division it gives m equal to 1.14, and if we can substitute it into the formula we get the m. It becomes y equal to 1.14x plus b. Now to find out b we need to come up to this formula called y minus y1 equal to m x minus x1. After substituting y1, m and x1 it becomes y minus 12 equal to 1.14 x minus 0. After further expansion it becomes y minus 12 equal to 1.14x because multiplying anything by 0 is 0, and then it becomes y equal to 1.14x plus 12. And if we superimpose the formula called y equal to mx plus b in over here, b becomes 12. So we got both m and b for our straight line between 2 points, which is farmer's place $12 and downtown $84. Now, since we came up with this formula by taking farmer's place and downtown, and if we substitute the x value, we should get the same y value. So let's do that. At x equal to 0, I am substituting x at 0 in the same formula. I get 12, which is correct. At x equal to 63, I am substituting 63 and then I got 84, which is also correct. So I know that my m and b values are correct. But what will happen to the rest of the points? Things will be interesting here because at x equal to 10, we get 23.5, whereas the value which is being plotted here is 28. At x equal to 25, we get 40.5 as against 36. At x equal to 48 we get y equal to 67, and so on if there are other points. So you can see that the first and last point will match because the equation is derived from that. All other points doesn't match in my straight line. So what will we do? We will try to find a straight line which is the best possible match by calculating the error for each points that are there in between these 2 points. The most popular error calculation mechanism is called mean square error. The formula is sum of all x minus x mean into y minus y mean divided by sum of x minus x mean whole square. Now come to linear regression. Linear regression is all about finding a straight line with least MSE, mean square error. This is what linear regression is all about. So whenever we create a model of linear regression, it just go on, keep on learning, try to come up with a straight line which is having least MSE for all the training data set. And that's all about linear regression. I hope I was able to clarify it in graphical format. Let's just go ahead and see how we do it in scikit-learn. Welcome to our Jupyter Notebook of Chapter 3, our second machine learning algorithm. As a recap, I'll tell you linear regression is a predictive model which provides the relationship between independent variable, which we call features or x-axis, and dependent variable, which we call label or y-axis. Before I go ahead and let you know how you can use linear regression in scikit-learn, I want to tell you why scikit-learn. So I am now going to expose the reason why I have chosen scikit-learn as a hello world for machine learning. Now, if you have gone through my chapter 2 KNN, you know that we have created the instance of the algorithm with a constructor by passing one parameter, in this KNeighbor classifier. After that, to train the model, we call the fit function with x and y value, and then we call the predict function on untrained x values to get the prediction out of the model. The reason scikit-learn is so good that almost all algorithm uses the same functions with same set of parameters. For example, linear regression is very easy to implement in scikit-learn if you have gone through my chapter 2, because in linear regression also we'll create the instance of linear regression. We'll call the same fit function and then we'll call the predict function to get the prediction. And that's why scikit-learn is very useful to start your learning journey in machine learning. So let me go ahead and import linear regression. I have imported the linear regression. Let me create the instance of linear regression. Let me just reprint the feature and label so that I can see it over here. Our feature are 0, 10, 25, 40, 56. And here downtown is 56. In the picture I have kept it at 63. Sorry for this confusion, but consider this is the value and these are the dollar value. And I just train the model by calling fit function with the feature and label. So my model is ready. Now let's come to prediction. Let me predict for 25. You can see that my prediction returns me 40. And if I want to predict for 7, my prediction returns me 19. And if I want to predict for even 56, my prediction returns me 77, not 84, because during the training it came up with a perfect straight line. So the MSE, mean square error, is less. And just like k nearest neighbor, instead of passing one single value, we can also pass a set of single value. Let me print the guess for. These are the set of values I want to pass into my model, and I have passed it into the predict model, and what I get in return is the prediction according to each of the features, each of the input features 7, 11, 23, and I get the value. And the difference between regression and KNN is that KNN looks for the existing label to associate itself with. Regression generates up data which may or may not be the label. And just as a last thing, let us plot this graph as a straight line. So you can see that the linear regression model always comes up with a perfect straight line where it matches the most. So in this particular case, the MSE, if you calculate, this straight line will have the least mean square error, and these blue dots, you can see that these are being predicted for this untrained value. So this is all about linear regression. I hope I was able to explain this in the best possible way and you are able to understand. If you have any queries, please write it in the comment section. I'll try to answer ASAP. Thanks a lot guys. Thanks for watching. Please take a moment to like, share and subscribe. Thank you. Thanks a lot.